Okay, today we're going to talk about the appropriate ways to sample, or a few of those ways. The first one is probably the most important one to understand throughout this year. It's called a simple random sample. We will refer to it as an SRS. And it's often thought of as the gold standard of sampling. In AP Statistics, we use it all the time, and it's one of the conditions that we'll check later in the year when we learn how to inference. To do formal inference, you have to make sure that you have an SRS usually. It's not always the best way to sample, and you'll understand why other approaches might be appropriate later on in the unit. Now, simple random sample. You see the word random. Random doesn't apply only to simple random samples. So what makes this unique is the fact that a simple random sample is chosen in such a way that every sample of size n has the same chance of being selected. So let me just kind of walk you through this for a second. So say I have a population of 100 people, and I want a sample where n is equal to 20. I would need to basically get my mind around how many possible samples are we talking about. Well, this would be a combination where I have 100 and I am choosing 20. And I did it in my calculator. I think you remember how to do that from your accelerated days. And you get 5.4 approximately times 10 to the 20. So that is huge. That's the number of possible samples that you could have. And every single one of those would have the same exact chance or probability of being selected. So that is what makes a simple random sample unique. And that's one of the things you need to get your mind around, is the fact that every time we create a sample, we're just getting one of those many available samples. And every single one of these samples is going to vary from the next one. Not that that's a bad thing, it's just the way that it is. It's not something that is done wrong. Variation is everywhere around us, so that's one of the things we'll focus on this year. So how do we create these random samples, or the simple random samples? First, we assign a label, and I'll go through this in just a second. It's really just going to be a numerical value to each member of the population. So this is known as your sampling frame. In other words, when you assign that label to every observation in your population, hopefully, that becomes your sampling frame. It's the group of individuals or observations from which you can sample. Ideally, the sampling frame should match the population. So say, for example, I would like my population of interest is all Peachtree City residents, and I want to survey them about some sort of tax or something, just something I want to find out about. And I am going to create a sample, and I use the Peachtree City phone book, like telephone book. And I go through and I label them and I create my sample. There is a problem with this situation, and it is the fact that my sampling frame, which is my phone book and all the observations in that, does not match my population. I have left out anyone who does not have a home phone, or anyone that doesn't have a home, or anyone that perhaps is unlisted. So there's all these different little subcategories or subgroups of individuals that I have left out. And in doing so, my sample is not going to represent the population in the way that I would want it to. Okay? So once we have our sampling frame, hopefully matching our population, and we assign our labels, we will then use a random number generator. And I'll be doing that in just a few minutes for you, or a table of random digits. And for us, in our book, it's called Table D. And if you ever need that, you can usually just Google it, and it'll pop up. It's also in our book. And you're going to select the number of observations required. Okay, so that's the basic process. You label, everyone in your sampling frame, you randomly select them, and then you would match them back, and that would become your sample. So one of the main considerations when you are sampling in this way is, are you going to use repeats? So to sample with replacements means that you allow repeats in your sample. Okay? If you do not want repeating observation or repeats, you can sample without replacement. Okay, so let me kind of scroll down. Usually we are going to sample without replacement. So usually you don't want the same observation in more than once. Now, if you have a large enough sample, sometimes it's not that important. So let me give you a little example in just a second. I'll talk about the stores down here in just a second. So you will ignore any duplicates. So you ignore random selection if it has already been selected. Okay. It is more common to sample without replacement. And the reason why is usually you don't want the same observation in your sample more than once. So usually more than once. Okay. Especially when you have small samples. And in just a minute, we're going to create a sample with 3 stores. And if we had the same store in twice, then our sample would not represent the population the way that it should. And a sample of size 3 is not preferred anyway, but especially with the small samples, having repeats can have a major impact on how the sample represents your population. Okay, so let's go through this process, and we are going to create our first sample. And that's table D. Let me go back to there we go, sorry. Okay, so the first thing we want to do is want to label, okay? So I'm going to come back and do that in just a second. I'm going to go with our state plan to conclude. We want to sample stores to create an SRS of 3 stores. We will assign labels. Now, we have how many stores? 1, 2, 3, 4. So 21 stores. So we're going to assign the labels 0, 1 to 21. Now, the 0, 1 may seem strange, but it's because you need the same number of digits when you use your random digit table. So make sure that you use the same size for each label, so same number of digits, which will match the number of digits for the size of the population. So in other words, the population is 21, which has 2 digits, so we need all of our labels to have 2 digits. So you're going to move across table D at line 101. We're all going to do the same line. Okay, we're going to move across table D at line 101, and table D is in your textbook at the back. There's a little link to it on the electronic textbook, as well as I put a link in it in Blackboard on the calendar, and then you can always just Google it. This is what it looks like. So I'm going to move across this line, the first line, until I have enough observations for my sample. So, I'll write those down for you in just a second. So we're going to move across and group by 2 digits. It's very, very important that you do that. And we will we'll make a choice for every single grouping of 2. We either select the numbers in the range if they fall between 0, 1, and 21. We will ignore repeats, meaning that if we've already selected it, we'll just ignore it and move on. And we will also ignore any numbers outside the range 0, 1 to 21. Okay? And then what we'll do is we will match back to the store. So we'll match the selected labels back to the stores that will comprise the sample. So let's go through this process, and you should see what line 101 looks like. Of course, you need to know what that looks like. So this is the actual do part, and the numbers that I see were 19, 2, 2, 3, 9, 5, 0, 3, 4. I'm just writing these out for you. 0, 5, 7, 5, 6, 2, 8, 7, 1, 3. So 2, 8, 7, 1, 3. And like I said, every single grouping of 2, and you can span across the break, has to basically be looked at, analyzed, and you have to make a decision about it. Okay, so as I go across, I'll either mark them as a selection. So 19 is good, 22 is outside of our range, 39 is outside of our range, 50 is outside of our range, 34 is outside of our range, 05 is in our range from 01 to 21, and we haven't used it already. 75 is outside, 62 is outside, 87 is outside, but 13 is in our range as well. So then we have to go back and we have to figure out which stores were 19. That's Star Jewelers. And then the next one would be 5. And that one was Carter's for Kids. And the final one is 13, and that is Mrs. Fields. So our SRS is comprised of Star Jewelers, and Carter's for Kids, and then I'll put Mrs. Fields. So that is how you would create an SRS. Okay, so let's kind of scroll down and work on a few more of these notes. These are this is the activity that we did in class, so we can pass over that. So now I'm going to talk about another really good sampling method that we'll talk about a lot in AP Statistics, but not as much as the SRS. It's called the stratified random sample, and you notice that it has the word random in it as well. It is random. However, it is not completely random. So the way it's basically going to work is a sample will be created by breaking or grouping the population. So grouping the population based on some characteristic called a strata. And then randomly selecting, and this process would be accomplished the exact same way within each strata, and you'll understand in a minute what that strata is, to form the sample. So strata should be blank and based on a characteristic which is suspected will yield different survey results. So strata should be similar within and different between. Different between. I'm abbreviating there. So similar within, different between. A great example of when stratification might be appropriate is if you want information from your Starsmall High School population, and say you think that the results or the survey results will be different based on grade level, you may want to make your strata grade levels, because a 9th grader may respond very differently than a junior or a senior, for example. Okay, so it is different from an SRS because every sample of size N does not have the same likelihood of occurring. Okay, so you use stratified sampling when the strata are more similar, or I'm sorry, they're less varied